So my name's Tim Smith, and today we're going to be talking about testing like a pro. It has a slightly different title on the sheet, sorry. Also, I don't use the correct title slides. This is an updated talk that I gave about 2 years ago, so the title might sound a little familiar. Some things are different because some testing has gotten a lot better, but the general idea is kind of the same. We're going to talk a little bit about why test, what you test, how you test, a little bit of like refresher course for people that might not have a development background. And then we're going to talk about how you're going to do it with Chef and how you're going to get great business outcomes from all of that. And then I'm going to mute things on accident. So the first question really is, why do you want to test at all, right? Like, there's a lot of reasons that people tell themselves about why they don't want to test. We can just skip this whole thing, right? And really, it kind of comes down to one of these things. It's hard, takes time, and it slows us down, right? I'm not saying that I've said all these things before, but I've totally said all these things before. Testing is absolutely difficult. It's absolutely going to slow you down a little bit. And it's going to be hard. Like, often the testing is significantly more work than the thing that you're trying to change. But it's super important. And the reason for that is pretty simple. Like, testing is our job. And that doesn't matter what your job is. It's your job. If you're a developer, you write software, and that software helps your business. Chef pays me. I write software. I write Chef Client. I write Chef DK. And obviously, Chef is doing that because they want their business to be successful. So I should write good software. It should be well tested. And if I do that, ideally, I'm helping my business out. If you're on the ops side of things, well, then you're keeping software running. And that helps your business, right? They have to have a product, has to be accessible. You want to do that, that's why they pay you money. If you're some sort of DevOps, SRE, whatever we're calling that today, it's probably going to change like next month, then you can really just kind of throw those slides together. You're writing software, you're keeping that software up. But the core takeaway from that is that your job is to bring value to your business. And obviously, if we fail, we're not helping our business. And that's how you end up not having a job. Pretty simple. So, unfortunately, faster and uglier failures are really becoming the norm for us. And us, I mean anyone who deals with software in any way, whether you're writing something that you ship, whether you're putting software out there continuously, whether you're in operations, failures are faster and uglier. And that's because we're not supporting simple LAMP stacks anymore. We have really complex sites, we have crazy microservice meshes, and we have services now that are so complex that we can't actually keep them in our head, which means we have to have tests because our brain can't be the tester anymore. And a great example of that is me. So I come from an operations background. Chef is actually the first job where I could say I was a developer. Feels a little weird. I made a lot of system changes back in the day. And this is a picture of me from a while ago. And I made a lot of good changes, and I made some bad changes. But it was totally OK because I didn't make a lot of changes. I was only making about 5 changes a day. These were changes that were done through wiki pages. I was printing out Excel spreadsheets for changes. I was making checks. I was signing my name. I was handing things to another coworker so that they could validate I had done it correctly. And then we put it in someone's desk where they would put it in a filing cabinet. So 5 changes a day. Our mean time to failure, even with a 2% failure rate, was pretty low. But I didn't like that. I thought like 2% is too high. We have all this human error we're doing. We should really automate this. And I brought Chef to this company I was working at. So post-configuration management, Tim, only has a 1% failure rate. Now all the human error, all the I was tired, maybe a little hungover, who knows, like whatever happens that makes you do the wrong thing, you read something wrong or you just clicked the wrong box, that all goes away. And you'd think that that would be like the fast track to promotion and bonuses and all that great stuff, but it wasn't because now I'm making 50 changes a day. And even though I have a lower failure rate, I'm failing way more. We're having more outages because we're releasing more often. And you kind of might see where I'm going with this. This is obviously not what we want. So we want our nice up and to the right graph in this case. We want that green, but we don't want the failures to be increasing at the same rate. And if we just maintain a 2% failure rate, or even if we have a 1% failure rate, but we're releasing faster and faster, we're going to have more and more outages. So we have to find a way to basically reduce our failures. And the only way to do that is testing. So let's all jump in. Let's talk about how we're going to go about testing our chef infrastructure. The first thing you might find when you look this up is that there's a whole bunch of different solutions, right? Chef's been around for a while, and there's a whole bunch of testing frameworks and solutions. You might read blog posts. Somebody might tell you, somebody like Joshua Timmerman might tell you from 2013 that X or Y is a great thing to test with. But it doesn't matter which one of these you use, because they really kind of fall into three camps when you're talking about cookbook testing. They're either linting, unit testing, or integration testing. And I'll go over what these mean. And the nice thing from this is they form this little pyramid totally by accident, and that is kind of an importance pyramid, we'll say. Also a difficulty pyramid. So linting. It is kind of exactly what this picture shows, right? This person is pulling some lint out of their pocket because you probably don't want that there. But linting is when we statically analyze our code, and we're looking at three things with that static analysis. We're looking at style, we're looking at syntax, and we're looking at logic. And the cool part about this is that we're doing this statically. What that means is that we're not loading that code. We're not executing a Chef client anywhere. We're not even firing up Ruby to do a require on Chef. This is all static. It's basically a giant regex. And you can do a lot of cool stuff with a regex. And you can also do a lot of cool stuff very quickly with a regex. So style. There's a lot of people that will say that style testing doesn't matter in your code. I think style testing is ridiculously important. Style is important, and style prevents outages. This code here, this wonderful set of phone wires, is going to be really difficult to troubleshoot for somebody. It's all there, and it all works. It's all hooked up correctly. But it's not done in a way that another person can look at it and figure out what's happening. You're not going to be the only person that touches your infrastructure. Even if you're in a one-person shop, at some point you're going to leave. Somebody's going to be responsible for what you wrote. They're going to have to understand it. They're going to have to troubleshoot it. Ideally, you have more than one person. You're doing code reviews. You want those people that are doing code reviews with you to understand that code. It's really easy to write code that's kind of crazy and complex, and your coworkers just are kind of going to look at it and gloss over, right? They might just hit approve when what they should be doing is reading it all the way, understanding it, and giving you feedback. That only happens when you have proper styling. The second one is syntax. So this is about, is the code actually correct for the language we're talking about? We're writing Chef, which is really just kind of Ruby. Is that Ruby code correct? Did I miss a do? Did I miss an end? Did I put an extra bracket somewhere? Is this code going to actually compile? And then the final one is logic. So again, we're writing Chef code. Is this the right thing to do for Chef? And we can do that. We can look at the code you write with a regex, basically. We can look for patterns. We can detect things that might be deprecated code or just places we know that you're going to probably have a bad time. And we can prevent you from having a bad time before you have a bad time, which is what you want. So what does linting look like in Chef? Well, the first thing we have is called Cookstyle. If you're familiar with Ruby code, Cookstyle sits on top of Rubocop. Rubocop is a really awesome linting engine for Ruby. There's like 250 different Rubocop rules. We've curated that list because some of those really make sense if you're a Rails developer. They don't make any sense if you're a Chef developer. And we've put together a list of rules that are appropriate for your cookbook development. And that just gives you a simple command so you don't have to manage what you want to turn on and what you want to turn off. Rubocop's pretty cool. It has autocorrecting. Cookstyle's pretty cool. Rubocop's pretty cool. It's got autocorrecting, so you can just run this against your existing code base, autocorrect all your stuff, never have to worry about it. And that gets you basically style. That also gets you syntax for Ruby. We also have another tool called Food Critic. Food Critic's where we get to be Chef specific. We are writing Chef code after all, so that's what we really care about. And this is going to give you output like this. Unfortunately, there's no autocorrection. That would be great if it had that. Also, that'd be kind of a little bit harder because some of these things are a little trickier. So this is just going to tell you things that you're doing wrong. They all have a Food Critic number to them. In this particular example, we have a bunch of different things that would make it difficult for you to share your cookbook out. These are like not having a source URL or issues URL, missing a license file. But then we also have some things that would get you in trouble even if you were in a private cookbook in your organization. So you're using some kind of older code, some not so great ways of converging a resource in Chef. And the cool thing is these all link out to a page. So this particular one tells you something I would hope you wouldn't run into. It's basically telling you that you're using code that is from the Chef before 11 era. So you're writing like 2012 chef code. And this would be difficult, right? Like somebody would read this and be like, why do you have this initialize definition in here with a super? I don't even know what that does. Like, what is this? And this is like the old school way you would do this, and the nice new way is like just default action, right? So it makes it super easy for other people who might not be deep Rubyists to see your code and recognize it. Also, we might break something in Chef later on because you're writing code from 2012, and you don't want to do that. So now we're fully linted, right? We've got all nice style, nice syntax. We're great with that. What do we do next? Well, the next one in that pyramid was unit testing. And this is where we get into actually writing tests. Linting is really just about warning you that you're kind of doing the wrong thing. Unit tests, though, are about looking at the components of your software. Surprisingly, surprise, surprise, they're called units. And then we're going to ensure that given certain inputs to them that we're going to get outputs back. And that really sounds weirdly programmy, but it does actually apply in a chef world. You have inputs. You write things in a cookbook. You have an operating system. It has inputs. On the output side, you want certain things to happen, right? You want like Chef to run. So how do we do that in Chef? Well, we have ChefSpec, which brings RSpec style unit testing to Chef. If you're familiar with the Ruby world, RSpec is kind of the de facto standard for how you would go about testing Ruby code, how you'd unit test it. And ChefSpec is an extension layer over that makes RSpec aware of Chefisms, right? We have metadata, we have cookbooks, we have recipes, we have to have an operating system. Those aren't concepts that you have in like a Rails app. They're specific to our own DSL that we've developed, so ChefSpec is aware of those things. So how do we test something? Well, this is an example cookbook here. This is the MyFace application. Maybe your next.com hit, it's the ripoff of Facebook, right? And it starts out as this simple recipe here. We have just three things. We have a package that we install. We have a template that we template out. It's got a simple variable in there. When it's done templating, it's going to notify a restart, and it's going to start that service up. So pretty basic stuff. This is kind of where like most of our recipes start. Now we want to unit test this. Well, what would that look like? Well, it looks like this. And the first thing you notice is that it's significantly bigger than that recipe. And that is true. Your tests will always be bigger than your code. This is kind of the unfortunate side effect of testing. And this is that it slows us down and it's hard part. It does take a while to write these things. Fortunately, there's a lot of repetition in this. You'll see from this that we kind of mirror the three different resources we have. But we have a little bit on the top, and I'm going to break into exactly what's going on in this. So the first part is we had this describe block. And in the describe block, we said MyFace default. So that was our default recipe. And what we're doing with that is we're doing a full in-memory convergence of Chef. So I'm doing this maybe on my Mac. I could be on a Windows box. But we want it to be on Ubuntu. So it has to be in memory. Obviously, we can't make changes to my laptop. We don't want that. I don't have a VM. We're not doing any of that. So we're specifying what the platform is. And then we're using a mocked out OHI data. It's from our project called FOHI. We keep that up to date with all the latest operating systems. So when you say platform Ubuntu 18.04, we go out and fetch kind of fake OHI data. And that is going to be usually good enough. It's going to make sure that when you go through Chef, it makes decisions like you're actually on an Ubuntu system. The NICs look like an Ubuntu system. The platform says it's Ubuntu. All the stuff you would need to happen there. The cool thing here is you could just say Ubuntu, and you'd get the latest Ubuntu. Or you could say 18.04. You can do whatever you want. It'll kind of match and figure the whole thing out. Once we're in that in memory, then we have a few it blocks. These it blocks where we're actually making a test. So inside of each it, we have some expects. So we're expecting to install a package, and we're expecting to create a template, and we're expecting that we start and enable that template, right? Those sound really familiar. Those were the same things we had in those resources. We have these things called matchers. These are the matchers here. These are basically just the name of the action and the name of the resource. So there's a whole bunch of those.
That formatting looks slightly different than what I've been used to. Is that something new?
This is the fancy new format. Yes, this is what gets updated for this deck. We have a new, simpler format, which you would see right here. Before, you had to do a whole bunch of crazy stuff where you would have to like really be like, oh, I'm using Chef Solo and all these, and I would have to figure out what my platform was. Now you just say platform. Makes it a lot easier. There's a whole bunch of new sugar in the new ChefSpec, and this is the ChefSpec experience in about the last year. So if you have stuff that's doing it the old way, you can rewrite it. You can use the old way. Under the hood, it's actually just doing the old way, but this is much faster.
Which version was that changed in of ChefSpec?
7.6. Some random version you would never guess. Yeah, should have been 8.
In a situation where you have numerous services or numerous packages, is there any way to tie in either attributes or?
You don't want to do that, and I'll tell you why. We'll get to it. Yeah, it's Ruby in there, so like if you wanted to slap some for loops in here and like just have a whole bunch of stuff and generate the same thing, you don't have to like generate the whole thing out, right? You could just have like a giant array of 100 things and it would test like 100 different package names. But we'll get to why you probably don't want to do that. So in the end, you run this, you get the default formatter, which is ... Maybe not the most helpful thing. But it finishes, right? And it finishes super fast. 0.3 seconds to run that. Took 3.3 seconds total because there's like weird file load stuff that happens in there. You had 3 examples. That was the 3 resources, the 3 blocks that we had. And it tested, right? And this is success, and everything is tested, and you're great. Except you're totally not. Because what I gave you there was totally useless. Your job was to deliver business value. That test delivered 0 business value. And unfortunately, most of the unit tests that we see are people writing unit tests kind of like that. We used to actually encourage that. There was a little reporter that would run at the end that would tell you how much your code coverage was, and it would encourage people to basically test every resource they had, and it would make them have an incentive to do the absolute wrong thing. And this is why this is wrong, right? We're testing 3 different things here. We were looking at install package, create template, and some service stuff. And like I said, those mapped pretty much exactly to the resources you had in Chef. There's no logic here that you were testing. You were just testing that those resources were defined in Chef and that they actually ran in Chef. And that's my job, right? That's not your job. I have thousands of specs that make sure that that's the case, that when you write service, you get service out the other end. I want you to actually test your business. So let's look at a slightly more complex example of a recipe. This one actually has logic in it. And this is where you really want to use ChefSpec. If you don't have logic, don't use ChefSpec. So in this case, we have different packages on different platform families, right? So we're going to say when we're on a Debian-like platform, we want MyFace. And maybe when we're on a RHEL-like platform or any other platform that's in our environment, we know that that package is MyFace-D because people can't agree on package names. So that we want to test, right? That could get refactored. Maybe that if statement becomes significantly more complex at some point, and we want to make sure that always on our Ubuntu systems we get one, and always on our RHEL systems we get another. And we can test that. So this is a more complex example, again, but we have the describe block, so we're doing that in-memory convergence, but we have 2 different contexts. And the first context is when we're on Ubuntu, and the second context is when we're on RHEL. And then we're going to check for that package. Do you check the service? It doesn't matter. You really don't want to do that. There's no value in that. But you do want to check this install package because that actually changed. And somebody could refactor that away. They could change that if statement, and next thing you know, you're not getting the right package on the right platform. But what about that config? Because we had a config that we were templating out here as well. And that had some logic in it, right? We could pass in an attribute to that if this clicked. There we go. We had this template resource. It had a variable, or it had an attribute that it used that passed in as a variable. And then we had like maybe a nice little herb like this. And this was our config. So we had, some arbitrary data. That can be crazy complex. I think we've all seen like horrible herb templates that do like the worst things ever. That one is trivial. But we want to test that when we pass import that we actually get a working config. Let's make sure that actually works. And that's value, right? Because often in like complex herbs, like things like the client.rb in the Chef Client Cookbook, often get broken because someone just moves an if statement to the wrong place or changes a case statement, and you end up with an invalid config. So this is a different example. Ignore the part where it says when all attributes are default, because that is totally not true. What we're going to do is we're going to do the same kind of thing, but we're going to provide the attribute this time. So we're going to change it as if we were the user consuming this cookbook. We're going to set that attribute, and then we're going to template out that config again. Again, we have logic here, so this is something worth testing. We want to make sure that we render a file, and that is going to be our MyFace config, and we can actually look into the content of that file. So we can use a regex. Again, like I said, I had a pretty simple example, so a regex is probably appropriate there. I just want to make sure that port equals 80 gets put into quotes properly. Maybe MyFace won't start up if there isn't quotes there. You could actually make it match in its entirety. There's a whole bunch of different options there. These are all very tons and tons of different matcher options that you have that are on the ChefSpec documentation. And this would allow you to do all kinds of crazy different things with how you check that content. So you make sure you're templating out the same thing. Now the second warning here, and there's probably really 6 warnings about things not to test, ways not to use ChefSpec, but the real warning about ChefSpec is that perfect specs are not going to catch a ton of failures. You see people that get really focused on building out complete specs, building out these crazy sets of specs that are going to go through every different scenario they have. But often you're not going to catch those things. And the reason for that is this. So this was, again, our cookbook we had here. And there's a whole bunch of assumptions that we're making. We're making assumptions like that package actually exists in our repositories. Is it there? Could I even get it? Well, when I write the spec, I have to assume that's true, right? I'm just making an assumption that that package will be available on this operating system, but it might not be. I'm making an assumption that that MyFace config is correct. I said it needed quotes. Maybe it didn't need quotes. It was an integer, maybe it should just be 80. And I'm making an assumption that, the service will actually start, right? When I say service enabled start, is it actually going to start? I can't do that in a spec. I have to kind of mock that all away, and I have to make a whole bunch of assumptions that those things will actually happen. So I could have perfect specs for this, and the whole thing could never work. So how do we do that? Well, what we really want for this to know that we have absolutely working infrastructure is we have to go through integration testing. Now, integration testing is where we combine all those components of our software, and that includes our operating system that we're running on, and we test that together. And that is real testing. It's a little bit harder, it's a little bit more expensive, it's more time consuming, but it's real testing. And that tells us that this will really probably work in our production environment. And that's gonna be a real chef run, right? And as we know, chef runs take time sometimes, especially from scratch. When we have to install these packages here, we have to wait for those packages to actually install. They have to get pulled down, they have to be written to disk, all those things have to happen. But when this finishes, we know that it actually finished. It's a real run. And we do that with Test Kitchen. So in Test Kitchen, we can define multiple platforms out, we can define multiple suites, we can test these things in all kinds of different ways, all the different ways that we would actually use it in our business. And there's a few different parts of Test Kitchen. If you haven't seen one of these configs before, the first part that we're defining is a driver. So in this case, I'm using Vagrant. I was just running this on my laptop. Vagrant can talk to VMware Fusion, can talk to Parallels Desktop, we can talk to VirtualBox, whatever. But this could also be something like EC2, OpenStack, Azure, wherever you want to provision the system. The second part is the provisioner, and that in our case is going to be Chef Zero. Chef Zero is kind of a faked out Chef server in memory. So this is going to be a client run that thinks it has a server, thinks it can do all those things. And then the last part is going to be a verifier, and we'll get into that. We're going to use Chef Inspec for that one. We've got a few different platforms we want to test on. If I was in Azure or EC2 or whatnot, I would be specifying things like AMIs. In this case, I'm doing this locally. So I'm going to be using Vagrant boxes. These are coming from our Bento project. So this is one of those nice things you get with Chef. You get all of the development of boxes. These are all up on the Vagrant cloud, or whatever they call it now, Atlas, whatever the thing is today. So we have CentOS 6 here, CentOS 7, and that's going to just mean the latest CentOS. So 6 really means like 6.10, 7 means 7.5 or whatever it is. There's a whole bunch of different ones there. So we have test boxes for like OpenSUSE, for Ubuntu, for CentOS. What we don't have is things that have licenses. Can't do that legally. We do have the Packer configs though. So if you wanted to start with those, we have Packer configs for things like Windows, SLES, Red Hat, all that fun stuff like Solaris that has licenses. So we can just run that test on those platforms. And then we have some suites. So this particular recipe we wrote here, maybe it has a client, maybe it has a server. We want to test both of them, right? We want to test the whole thing out. We want to integration test the whole thing. So let's run both the client and the suite. And you might notice there that those are running a test recipe. You should write a test recipe. Your recipe or your cookbook might just be shipping resources. Well, you want to test it the way you're using it. Even if it's just a bunch of recipes, it probably has attributes. You want to test it the way you would use it. So you want to set this test suite up to match the most production-looking way you can possibly test it. If it's resources, think of the way that a person in production will use this. Write some fake services out, utilize all those resources, do it in a test recipe, and get going with that. When you put this all together, we get all those different platforms we have, and we get them on both our client and server, and now we have 8 different tests. And we're going to converge these all, and that's going to be obviously 8 different chef converges. We have to spin up all those systems. Like I said, it's going to take a little while. But once it's converged, what does that tell us, right? Even if we converge it, do we know that we have a reliable solution? Do we know that this is production ready, that we're going to deliver business value? Maybe not, right? Because I want you to test your business. I don't want you to test mine. Mine is the chef client converging. Yours is you actually getting a system that is in the shape you want it. And we want to make sure that the system, even though it converged, is correct. Because again, we could totally converge something and it would be absolutely useless to our business. And for that, we're going to look at Chef Inspec. So Inspec is our compliance automation product. Turns out that compliance automation is really similar to testing, which is fantastic. In compliance automation, we want to make sure a thing is a certain way. Well, in testing, we want to make sure a thing is a certain way. So we get all the benefits of Inspec, all the development that goes into Inspec for all this compliance stuff. We get it for testing now, which is great. It lets us write simple RSpec-like tests. Again, we have RSpec here because we're in the Ruby world. It's a little bit different RSpec, but it's going to ensure the state of the node. And the really cool thing is we have 326 built-in resources for checking things. I got to update this. It was pretty cool. The last set of slides, it said 82. I was like, whoa, that's a lot more. And we're always adding more stuff because people want more things to be audited, right? So the more things they want to audit, the things they care about in their environment, you get that stuff for free, which is cool. And these are some of the things you get. The really basic things you would expect, right? We can like check that a package was installed, or a file was created, or a directory was created. And not only that those things were created, but they were created the way you wanted them, which is the really cool part, right? We want to make sure that file exists, it has the right owners, has the right mode, all the things that would matter for your business. We also have a bunch of deep system stuff. So if you care about SSL certs, if you care about grub config, IP tables, Windows features, crazy things like bonding, because no one ever gets that right, you can audit it.
Tables yet?
It's probably in there, I don't know.
Last I checked, it wasn't. But maybe.
You should write it. It's open source. That's how this works. Most of them actually are written by the community, which is pretty cool, except for the cloud ones. Like, those are us. Yeah, so you can also dig deep into your app config if you care about things like how Apache's set up, how your Docker containers are set up, if you're running Docker directly on the system, all the different databases you might care about. Yeah, you could like totally configure Oracle and then you could audit it with your tests here, which is pretty crazy. Or like IIS, right? Windows is cool. And it would look like this. So this is an example I pulled from our Tomcat cookbook. Our Tomcat cookbook has a test cookbook, and it exercises all the resources in it because we want to make sure that it works the way people would use it. So it sets up some example Tomcat sites. This one is Hello World. We want to make sure that it's actually creating that directory right, because one of the things in the cookbook is it has a resource that allows you to change the owner and the group and the mode. I want to make sure that that actually works, right? Like when I hand it off to a person that's in another team and I say, hey, look, we got these Tomcat resources. They're pretty cool. I don't want them to come back and be like, none of the mode stuff works. So we can write some tests out that say it's a directory. It's owned by this person. You know, it's owned by this group. It's owned by this mode. And we're going to be super sure that that is the way it should be. But we can do better ones than that. You know, we've got a whole bunch of different tests. These run. This is confidence. This is, again, that Tomcat cookbook. The most important one that I would point out, the most important two, are these two right here. So again, we want to test what actually matters to our business. We want to test that we can pull up that site and that it comes back with the data we want. The file mode really matters to me, but maybe not to the business. And that is about test assumptions and desired outcomes. So we have two different kinds of things we're testing for here. We have system tests and we have business tests. System tests are me caring that when I hand this to another group of operators, that things like that file mode and that user and that group work, or maybe I really care about how that network bonding is set up, but the business doesn't care about how the network bonding is set up. They really don't care. What they care about is that when you hit that Tomcat site, that you get back that content. So you need to make sure that when you're writing these, that you're thinking about the things you care as an operator about, but also about the things your business cares about. Because at the end of the day, this cookbook is supposed to set up our Tomcat site. So we should test that the Tomcat site is up. All right, so let's look at a little bit of testing recap, what we've done to this theoretical set of cookbooks we have, even though it was like 4 different cookbooks. We've style linted it with Cookstyle. So our Ruby looks good, right? We've syntax linted it. So we know our Ruby is great. We've done that with Cookstyle and FoodCritic. We've tested our logic, our chef logic with FoodCritic. We've logic tested everything. Again, only things that have logic, not things that don't. We've done that with ChefSpec. We've done a full convergence test, so we know that Chef is going to run. I'm not going to push out some change that makes every single Chef client explode with a compile error. We did that with Test Kitchen. And then we did some outcomes testing, because we actually want to make sure that not only Test Kitchen converged, that Chef ran, but we got the thing we wanted. So when we have all this put together, this really means that we have some confidence. And that means that we're going to deploy something to production that is, maybe not going to get us fired, which is always good. But how do we use these tools, right? Because this is a whole bunch of different tools. How do we kind of put a nice little bow on that and put it all together? And also that we want to test locally and automatically on each change. And that's kind of the important part, right? We want to make sure that we have a local developer experience for this. This becomes part of your workflow, but this is also something we can take into a system that runs every time somebody makes a change. We have a tool that most people probably don't know about. It's called Delivery Local Mode. This is part of our old delivery product, now known as Workflow, but the command line is still delivery. It has a little mode that they actually wrote for me because I was writing so many cookbooks and I complained that the workflow was really bad for testing them. So they put together this little tool. It's in Chef Workstation. It's in Chef DK. It's just some sugar that makes it a little bit easier to do some local testing. And what it is you have phases. You have this single config file. Any cookbook you have, MyFace or whatever, you create a delivery folder, which you probably already have in your cookbooks. If you use Chef Generate, this file is already there. You just don't know. It's called project.toml, and in there you define all these phases, and these are the things you're going to run. So the first one up there is actually ChefSpec, and then we have Cookstyle with some flags we want to give it, FoodCritic's running. The things we don't want to run, we just say we're going to skip. And then we have Test Kitchen. But hopefully you have more than one cookbook. If your infrastructure has one cookbook in it and you're getting paid, that's really awesome. That's not anything I've ever managed. So you don't want to have this file in the same place. And this was kind of the pain point that I had, was at Chef, when I first came on, I was managing all of our cookbooks. And at the time, there's about 200 of them. So if I wanted to enable or disable a test or change exactly how we tested, maybe there's a FoodCritic rule I want to disable, I didn't want to have to do it in 200 places. And you probably don't want to do it in 20 places or 200 places or 10,000 places or however many cookbooks you have. So you can just source a remote file. In this case, we use the same feature in all the Chef cookbooks that we test. We just source from GitHub. One of our GitHub repos has the file in it. So it's still nice and tracked in source control. But all of our delivery configs just look like this. They just say remote file, go grab it, do whatever you do. Which means if I want to enable or disable a FoodCritic test or want to change how ChefSpec runs, maybe I want it to have like the verbose output because the dots are useless, I can just do that in that single repo, commit that up, get that merged, and boom, all my tests do that, including all the tests that are on the local workstations. Because even a developer who doesn't have it pulled, they might not have the latest stuff, they're still going to be grabbing this remote file when they run the command. And the command is this. So delivery local all, which just means I'm going to run delivery local mode, and I want to run all those phases. You could call out those phases individually. You could just say like unit or lint or whatever. They're delivery phases, so the names are a little different. But you could also just say all, and it'll run the whole thing. The next question, though, is how do we run this automatically? And this is where it gets a little tricky. In previous years, I said, let's go set up Travis, and I'll show you how that works. But that's not really the state of the world anymore. You need to get a CI system. You need to run this on every PR. You need to make sure that when somebody makes a change, I don't care if you're in Stash or GitLab or GitHub or whatever. When someone makes a change to this repository, you test it before you merge it in, right? You should not be putting anything into your master that hasn't been fully tested. The problem is there's like a million CI systems now. I could tell you about Travis. We have that in Chef. If you want to see an example of what that looks like, go pull a Chef cookbook up, crack it open. You'll kind of see how we go about doing that in Chef. You could use something like Azure DevOps pipelines. The Microsoft folks have a pretty cool setup with that. You can check out some of their configs, and there's some other stuff, other people using that. You could also look at Circle CI is another really good one that I would recommend, and the sous chefs have that. They have a great example of how to set that up with orbs, which is a really great way to get everything set up. But once you get that set up, once it's running, once you have that fully tested, basically what you're getting at that point is confidence that you're not burning your business to the ground. And at the end of the day, like that's what you're trying to achieve here. You're trying not to break your business. You're trying to deliver value to your business. And if you properly test those changes, all the changes, even the trivial seeming changes, if you test them all before you put them into production, then you should have confidence and you should, have that end result of not burning your business to the ground. Not to say it won't still happen occasionally, but it'll be better. So go home, test the world. Just please don't write bad chef specs because they're really bad. And we have some example files up. This is some config files of things that I didn't get to cover as much. It has example kitchen files with kitchen vagrant. It also has an example kitchen dockin file, which is how you would kind of set up test kitchen in a world where you didn't have access to VMs because you're in CI, all you can use is like Docker containers. So check that out. And that is all I have. If anybody has any questions, I'm last, so I can just talk. What's up?
In the delivery tunnel, you had the kitchen test,
Yeah.
which if you have multiple suites, it's going to test those in serial.
Yep.
Right?
Yeah.
Pat, you could add a parallel flag there too. That's going to put a pretty heavy load on the node.
Yeah, I mean that's kind of the one downside you get with the delivery local mode is it's pretty static in what you can do, right? Because you just have a single config, so you're just going to be saying, I want to run test kitchen. Maybe you could pass concurrency into it if you were like, I don't care if I run 10 boxes at a time. I've got tons of RAM in whatever my CI system is. But yeah, once you're not in an environment you control, like once you're not running these CI tests in something like Jenkins where you can just put it behind a beefy box, that's probably not what you want. That does start to get a little trickier, and that's where I think you get into the CI world of saying, hey, maybe in our CI, we're not using the full delivery local mode set of phases. We skip that kitchen one because we want that to fan out. And that's what I would have shown if I was digging into the Travis stuff is kind of some of how we're doing that. We have a matrix set up in Travis so that at the same time we're testing all those different kitchen tests. Because for some cookbooks, there's like 60 different kitchen runs that have to happen. I'm probably not even going to do that on my local system. When I run delivery, I'm just going to run the phases and say I care about Cookstyle and ChefSpec and FoodCrig. I don't want to spend 3 hours. I'm not doing that. I got better stuff to do.
So it looks like delivery essentially replaces what we've done in the past is usually just break integrate commands. That's essentially kind of one way to looking at it.
Yeah, that's exactly what it does. So I had a rake file, and I passed it around all my repos, and I used this really cool differ from my Windows days called Beyond Compare, and I would sit and just diff with Beyond Compare and be like, oh, let me pull up my 100 repos and copy this because there was things that were different between some of them. So I couldn't just for loop and copy the thing. And it was awful. And you don't want to do that. And then I was complaining about all the duplicate work I was doing. And someone listened, some manager listened, and they were like, we're going to give you 1 week of this guy on the delivery team's time. And it was basically like, they're going to put it in the delivery command, and that's Rust. And he's like the only guy who knows Rust at the time at Chef. It's like pre-habitat. And he'll write this thing for you. Just tell him what you want. And out comes delivery local mode.
Would you elaborate more on the distributing your tests to a Git repo so that you don't have to keep rewriting the tests on every cookbook that you do?
I mean, you're going to... There's certainly some strategies of reusing the tests, but the tests that you write are going to be really specific to what the thing is. So I don't know how much reusability you're going to get from tests that actually have a huge amount of value. There's some tools out there that like auto-generate specs and stuff, and that sometimes works, but again, like a lot of times what you're doing with that is you're one-to-one matching those resources exactly. And if you do things like that, like I've seen tests where it's like, I'll just grab the attribute and then test that. The problem is like what you actually want to catch is when someone changes the attribute. So if you just read in the attribute and write a test, well, that test's always going to pass, right? Like there's a lot of the strategies about like kind of reusing tests make for tests that are sort of pointless outside of testing Chef, which is a fine line to walk sometimes. But you definitely want to make sure like, unless every one of your cookbooks looks exactly the same, the test probably shouldn't look exactly the same, I guess would be the answer. Anybody else?
In the same manner that you created that remote URL for delivery, is there an equivalent for kitchen YAML?
There's not a way to remotely source in the kitchen YAML out of the box. That being said, the crazy thing in the kitchen YAML file is that you can just put any sort of herb in there. So if you wanted to just like slap some Ruby inside of your kitchen YAML and do some wild stuff and like use Ruby to go out and fetch a place and then drop stuff, like you could do that. I've seen people do that. It's terrifying, but that's not a feature, and it probably should be. Now I think about it, and I don't even think it would be that hard. Someone should put that feature request in.
We have about 300 or 200 cookbooks. And
Yeah.
Half another guide, and every time I create a new cookbook and add that.
Yeah, I mean, especially if you know, like, it's a little different in community cookbooks because different cookbooks, like, you know, maybe support a different platform, but like, there's a lot of duplication, and that's kind of one of the cool things that the Microsoft dudes have set up for their test kitchen stuff, where they're like passing in the platform they want to test in the individual cookbook configs, and that is some of the cool shit you can do with the Azure DevOps pipeline. And that's sort of like, we also have a little bit of that in sous chefs where like you have to abstract it, but a lot of that depends on what your CI platform is. And then you get into wild, crazy custom stuff. There's examples out there of ways to do that kind of stuff, but nothing, that's not a feature of Test Kitchen out of the box.
I think you mentioned with the new ChefSpec, you can just specify a major version of a platform. You don't have to worry about the minor versions.
Yeah.
What's exactly in Fohi? Is that also about that same version change? Because that's one of the most annoying things we have to do. Is like,
Yep.
I need to get update all the time.
Yeah, so Fohi is like, I've got this, I actually have a kitchen YAML file for Fohi and then a custom kitchen driver. We're really abusing Test Kitchen. We're using Test Kitchen to go out, spin up a system in EC2, install the Fohi gem into Chef, and then generate the data and copy it down to my local system. So I run that, and it generates like a whole bunch of VMs. It spins up like, you know, all these different versions of CentOS, like 1 billion of them, and all these different versions of Red Hat, and pulls that stuff all down. And we do that like when there's a new version of Chef. So I just did that for Chef 15. Took a super duper long time. But we made a mistake, I would say, a long time ago of saying that we're going to name the version of things like CentOS. So you would theoretically have like CentOS 5.0 all the way to 5.11, and that's going to be in all 11 files. And that eats a whole bunch of disk space, and Fohi became one of the largest gems in Chef and super wasteful in terms of like what our installs look like. So we started deprecating old versions, which forced people then to start getting deprecation warnings, and like that just makes Chef suck. Like that's a bad user experience. So that was what that change was. Code Ranger actually put that in. It's a super cool one where it just sort of like does some fuzzy matching on it. So yeah, if you write CentOS 6, you just kind of get the latest CentOS 6. But if you really, really cared about CentOS 6.9, 6.9.
On the topic of Fohi, Fohi collects a lot of information about the operating system, but it also collects a lot of information about the hardware.
Yep.
And so there's actually going to be lots of variations in hardware too. But you don't get different sets of Fohi data if you specify an operating system.
Not out of the box. Yeah, you can generate your own Fohi data. You can actually give it your own stuff, which is pretty cool. probably for like your sort of setup. It's pretty neat if you had like cookbooks that are setting up like, say, hardware systems where you had specific disk setups, right? Like I used to write cookbooks to manage Cassandra, and like that's sitting in a system that has a ton of disk. So you, like a big thing about you writing that cookbook and it working is like what it does when it has 16 disks versus what it does when it has 8 disks or 4 disks. And that's logic, and you want to test that, right? That's a fantastic kind of thing to do with ChefSpec. That is a horrible thing to do with Test Kitchen. It just doesn't make any sense. So yeah, you'd spit out some custom FOHI data. You would go to those real systems. I don't know how to do that off the top of my head, but I'm pretty positive that in the ChefSpec and the FOHI repos, it has somewhat examples of how to do that. If you need to make it exactly match your business systems. Like I need this to do different stuff on an HP versus a Dell. Because my old data center is all HPs, and they're weird, and now I have these cool Dells, and they're different, and like there's actual cookbook logic that does different things. Anybody else?
In the unit testing, you're talking about a cookbook testing your recipe on. What about with more modern practices of doing use of custom resources?
Yeah. That's the really cool thing, and I wish I would have put it in, because then I talked fast, and I would have had time. But the really cool thing you get in the new ChefSpec is that you actually can test custom resources. One of the reasons I told people not to use ChefSpec in the previous version of this talk was that you couldn't test custom resources, and we obviously want people to be writing custom resources. You can tell it in a really nice way, like, hey, I want you to test this custom resource, and the cool thing that you can do with it is you can be like, here's how I'm using the custom resource. So before you had to like create a test recipe and you have like 50 different recipes in it, and you would just be like, have ChefSpec converge that one, and that one, and that one, and that one. And now you can just say, inline of the spec, like I have, for my Tomcat cookbook, it was a Tomcat install and a Tomcat service recipe. You could say, when I pass this property into Tomcat, install, it creates that directory that way. And you could do that all in a spec, and you could test all the different ways that you might use those properties. And that's really perfect because your resources a lot of times have pretty crazy complex logic in there. They have default values. You want to test those defaults. You want to test, like, it doesn't let me pass a string in here, but it does let me pass an int, and you can do that all in unit testing, which is pretty cool.
Are there any community cookbooks that have a good example of a Jenkins file for a CI pipeline?
No. Yeah, probably somewhere. There's definitely people that do cookbook testing with Jenkins. Somewhere Chef has a plugin for that we shipped. We were like gonna make it a product, and then someone vetoed that, so we just put it on a repo somewhere and didn't tell anybody about it.
Do you think Jenkins is an okay choice for CI for cookbooks?
I mean, if you have a Jenkins server internally, sure.
That's what we use.
And the nice thing when you're doing Jenkins is like all the problems you have in like a CI system, like whether you're running Travis or whether you're running Circle CI or when you're running Azure or whatever, like you're sitting in some sort of environment where you don't control it. So you can't just spin up VMs. You can't run Test Kitchen. It's in a Docker container. So you have to do things like docking because you still can start a Docker container there, but you don't have the full control you would have in your environment. But if you have a Jenkins server, it's sitting in a physical data center where you can run like virtualization, it gets way easier. You have to use Jenkins, but there's a trade-off there. As someone that spends his day in Jenkins, I can say that.
This might be an obscure question, but in Chef 15, you're now able to share properties of resources.
Mm-hmm.
Would we be able to do that in our ChefSpec as well?
Do you mean the copy to stuff?
Yeah. Because you want to be able to test those properties.
I think you would be able to test that just fine because that's going to happen like before the point that ChefSpec gets to the format of the resource. So I don't think ChefSpec would even be aware of that in the best possible way. Like it just wouldn't even be aware of it. Yeah, I'll take one more or two more. I'll take that out there.
So when using Inspec as a verifier in Test Kitchen, one of the problems that we have is that it doesn't have the ability to access those attributes that are defined in the first.
Yeah.
We have like hundreds of attributes defined, where essentially we have to create variables again in the Inspec test cases. And the problem is that if you change these attributes later, you have to remember to go and change the variables again. So have you like figured out how to actually get it to
there's some talk about that sort of scenario, but not in testing, which is pretty applicable of like, Inspec need to know more about Chef that it's running on. And I know that the Inspec folks are doing some stuff with that. I'm not sure what of that you get through the kitchen Inspec driver. I haven't really run into that before, but if you want to shoot me an email, yeah, or talk to that guy.
We just specify the kitchen directory in the kitchen YAML, and then kitchen loads in a file, I think it's called dna.json. We basically take that file in the kitchen instance and load it in, and it's JSON file.
That's the only way we figured out.
Yeah.
Yeah, there isn't like any.
A feature request might be a good one. I don't know if we'd get to it, but it'd be good to at least get it written down. I'll take this last one here.
Chef client, is it supported on RHEL 8, 14, or 15?
Yeah, totally. It is. It's not in our test matrix. If you were here for the last talk, you saw that crazy big test matrix we had. We build for the lowest platform we support, and that is so we get like the oldest glibc compatibility, and that usually gives us compatibility outwards from there. So like on Ubuntu, we build on Ubuntu 14.04, and then we test on all the platforms we want to say are officially certified. We're in the process of kind of ripping out our whole Jenkins infrastructure and going to BuildKite. And because of that, I kind of got like a stop, like no more platforms for this release of Chef, which meant we didn't get a RHEL 8 tester, but we got some RHEL 8 support in. Like Facebook was really insistent that we had that support for a long time for their infrastructure. And we also have been supporting Fedora. So Fedora is kind of like tells us when that stuff is coming, right? Fedora 26, like I think it was 26 or 27, DNF dropped, and Chef didn't support DNF, so like all of a sudden packages didn't install. And we're like, we should probably fix that because that's going to be RHEL 8, I would assume, and that was RHEL 8. I spun a box up. I put it into the FOHI data, so the new Chef DK is going to have that out of the box. The cool thing with FOHI too is if I add more files into that, if it can't find it locally, it goes and reaches out to GitHub. So if like you're on an old version of Chef DK and you test and you put in, Red Hat 8, and locally it's like there's no Red Hat 8, it stops at 6 or 7 here or whatever, then it'll be like, let me go check on GitHub real quick, and it reaches out to that repo and it says like, oh, there's an 8.json, and it'll pull that down and test it. But yeah, it should work. If there's stuff that doesn't work, like file an issue. All right, I'll be outside, also drinking.